All right, so we're going to start number 4. A block of mass m, 5 kilograms, is hung from a uniform cylindrical pulley, radius r equals 15 centimeters, and mass m, 8 kilograms, and it's released from rest. What is the speed of the block as it strikes the floor 2 meters below its initial position? Okay, so I feel like some of you might be led to do kinematics, but again, we saw something unique about the previous problem. I guess it's actually not unique, that we might have a tool as far as the net energy goes, right? The net energy, and this is the true form of it, the net energy does not change, right? The total energy is only transformed. And in this case, the hanging mass is m, little m, and the wheel is big M. So now it's actually really clear as to what's falling, right? Where is it getting its energy from? Gravity of the hanging mass. And so we're transforming gravity initial for the first mass into kinetic for the rotating. So 1/2, let me just write kinetic. Kinetic rotating. And then, yeah, the hanging mass still. The hanging mass is still linear translational motion, okay? And so we still just have the block hanging mass is mgh. And k rotational, that's the big one, right? Is 1/2 I r squared. No. What is the equation? 1/2 I omega squared? Yeah. Okay. Plus, what's the translation? 1/2 mv squared. Okay. We need the speed as it falls. So again, we just have to transform these two into things that we know. We know that I equals, well, we're on a disk, right? We're on a pulley.
So 1/2 m squared.
1/2. And I'm going to use capital M to distinguish it, because that's the disk. And what's the omega? If V equals R omega, what's omega? V over R. All right. So we have little mgh. We're going to plug into that. The 1/2 stays the same. But then we have I, which is also another 1/2. 1/2 m r squared. And what else can we plug in? V over R? And then that gets squared. Yeah, and then our r's cancels out. Plus 1/2 mv squared. Can I cancel out my m's? No. Two different sizes. Little m, big M. Okay? But that's okay because they gave us numbers. We need the speed. And so we have mgh Can I factor out v squared? Is that something I can do, right? Mathematically, I can factor out v squared. So I've got 1/2 capital M plus, sorry, that's 1/4, right?
Yeah.
1/4 capital M plus 1/2 lowercase m v squared and now we can just plug things in to find v. In the end, we've got the square root of mgh over 1/4 m plus 1/2 m. And you know what's really weird? Is that last time it was kind of difficult because we were talking about how this equation inside here would have been, it's similar to like, this is the force of gravity, but in this case it's the energy of gravity as we take out the inertial values. So it's just GH. Is equal to V. We have little m, 5. We have G, 9.8. We have H, 2. We have big M, 8. So we have all our variables. Plug it in. And we should get, hopefully, our answer, 4.67.